In this exercise, I'll walk you through a basic variable length subnet masking calculation and addressing design. Now, in this activity, you're given a topology and an addressing table and directions on how to actually go about doing this. And if you've done traditional subnetting, you're used to every single LAN being the same. So it's the exact same number of bits borrowed. But in this scenario with VLSM, you have the scenario where you have different hosts. Now, why do we need to change the subnet masking when you have different hosts? Well, when you're using traditional subnetting, everybody has to use the same mask, or all networks have to use the same mask. And when doing that, that works great if you have the same number of hosts across all your LANs. But in this scenario where you have 50 hosts on some, you have 20 hosts on some, you have 12, and then you have these serial links, that would not be very effective to use the same mask throughout your network, because that would create a lot of waste. And with the IPv4 address depletion, you want to reserve as many addresses as possible. So what I plan to do is to walk you through the process that I would typically use when I am teaching students in the classroom how to subnet. And the way that I usually approach this is looking at your address that you're being provided, and then starting with your largest number of hosts, so whichever LAN has your largest number of hosts, and then working my way from the largest to the smallest. So when looking at our instructions here, in this scenario, we're given the 192.168.1.0 network. That is a Class C private address. Okay, and the only way to really know that is just to memorize what your private address ranges are. So for Class C, it's 192.168, and then anything after that. Now we're given the 1.0 with the /24, which means the first three numbers are the network numbers. So the last octet is the only octet that we can really use to subnet out and assign our addresses. So that's the addressing scheme that we'll use. I have listed several things in this document just for a time saver, for demonstration, and one of the things I've listed is your chart. So if you need your binary decimal numbering chart, it is here, but you should memorize that, because you will need that not only for choosing how many bits that you need, but it is useful for determining your subnet mask as well. So I would encourage you to memorize that if you do not already have that memorized. So what I've done here is just written down each one of the networks from the largest to the smallest. So you see the two headquarter LANs are 50 hosts. You have branch 1 that has 20 hosts each. This should be branch 2. And in branch 2, they have 12 hosts each. And then you have serial connections, and you need to count for your serial connections. So this is the scenario that we have. So let's kind of look at our directions and see what they say, because this is similar to what you would have to do for some of your lab assignments. So in this scenario, they tell you how many hosts, which is just what we looked at. So the first thing you would do is examine the network requirements. You would need to figure out, well, how many subnets do I need? What is the maximum number of IP addresses for each subnet? So this is what we have written in the chart here. And determine how many addresses are needed for each of the LANs between the routers. And then they also ask you questions like the total number of addresses that you would actually have. So the first thing that you'll do is to determine the subnet information for each network, beginning with the largest network segment or segments. Again, this is what I have done over here on this right-hand side, is I've looked at my topology and I've written from the largest to the smallest. Now, one of the questions you were asked is how many networks you need. Well, if you write each network from the largest to the smallest it will show you how many networks you need. It automatically accommodates for the correct number of networks. So 1, 2, 3, 4, 5, 6, 7, 8, 9 total subnets. So that is a total number. Remember that between each router interface is another network. So branch 2, for example, has 4 interfaces. That means it has 4 networks attached to branch 2. Headquarters, same thing. And then over here, branch 1 would be 4 networks also. Each one will have its own subnet address, and the mask will be according to the number of bits borrowed, or your subnet. So largest to smallest is what we have. Now, when you're looking at this and trying to accommodate, for example, the 50, so you need 50 hosts. When you are borrowing numbers according to your subnetting rules, you're going to borrow left to right. Well, you're going to look at your numbers left to right, and when you're looking at VLSM though and accommodating for host, you will actually go right to left. That's because traditional subnetting goes left to right because it's accommodating for the number of networks. We're going to accommodate for the number of hosts per line, which will accommodate for however many networks we have. So if you're starting and you're going right to left and you're accommodating for 50, what you'll need to ask yourself is how many bits you need. So you start off by using your little chart. Well, what's 2 to the 0 power? Okay. What's 2 to the first? What's 2 to the second? What's 2 to the third? Okay. So that's what each of these are. So that's why you will need to memorize the chart. So if you are accommodating for 50, you would go through and, well, is 2 to the 0 enough? Nope, that's not enough. 2 to the first is 2, that's not enough. 2 to the fourth is 16. 2 to the second is 4, 2 to the third is 8, 2 to the fourth is 16, 2 to the fifth is 32. Okay. So now we are here with 2 to the 6. So 2 to the 6 is 64. That would accommodate for this. So if you needed these two numbers, which is where we would be for network, because these three, I'll shade these in just to make it a little bit easier. Okay, so in this case, we've said we need these 5 bits for the host portion. So I'll even write that in there just to make it a little bit easier. So that would mean this would be the host portion. This would be the network number. So I'll make this a different color. I don't know if I'll be able to get it all in. But that would be the network number. Okay, so that's where your division would really be between network and host. So how many bits would you need and where do you draw the line? So that's actually those two. And in order to get your subnet mask, you would need to add the value of the 128 and the 64. The 128 and the 64 is 192. So we were already working with 255, 255, 255.0 for your default mask because of the /24. So now it will be 255, 255, 255.192 because of the value listed here. Go up, and for time's sake I filled that in. Now let's figure out what your slash notation would be. What would the slash notation be for this? So if you started off with 24 and you added 2, 24 plus 2 is 26. So this slash notation would be indicated here. You would do the same thing here. Okay, so let's go ahead and list, so you can see here, I have 1.0 as our starting point. Okay, that's our very first number. Now, the next thing you would do would be to look at the next line. Okay. How many do we need here? Well, this is going to be the same thing, right? This is exactly what we did before, the same number, so I'll go ahead and fill that in. So it's going to be the same slash notation. We'll come back and fill in these other numbers in just a moment. But let's go down and look at the 20. So if we have 20, we need to use the same procedure we did up here. And how many bits do we need to borrow to accommodate for 20? Is 2 to the first enough? Or 2 to the, 2 to the 0 would be equal 1. 2 to the first would equal 2. 2 times 2 is 4. Okay, so that's 2 to the second. 2 to the third gives us 8. 2 to the fourth gives us 16, but this one would work, right? 2 to the fifth is 32. So 1, 2, 3, 4, 5 bits, okay? So 5 bits would be your host. We would have 3 bits for network. See if I can shade this in correctly. So if you have 5 bits, 1, 2, 3, 4, 5, okay, then you have your 3 bits for your network number. You have the 128, the 64, and the 32. Okay, that would give you this 224. Now, since you started with 24, in this case 24 plus 3 bits for network, that would give you your slash 27. So that would be the same thing for each of these two. We have the 12. So what do we need to accommodate for 12? Well, you start asking yourself again, is this enough? No. Is this value enough? No. Is this value? Okay, to the second. So then you go to the next one. Is this enough? So if you're looking at 2 to the 4th, okay, so if you have 4 bits, 2 to the 4th is 16. Okay, that would be enough. No, shade in the correct one here. So 1, 2, 3, 4 bits. And notice this placeholder right in front of it is the 16. Then if you have 4 there, then you have 4 for your network. Okay, and 24 plus 4 for your network will give you the, 28 for each of these. And then your mask would be the value of 128, 64, 32, and 16. Okay. So 128 and 64 is 192, 224, and 240. Then your serial links. Your serial links are easy, and they are always /30. Now, why is that the case? Because with your serial links, you always use a /30, which would be up to this mark right here, because this would give you the total number that you would need. You need 4 bits. And then that would be remaining 6 over here for your network. Now, could you use just 1 bit? If you used 1 bit, that would only give you 2 options. By using 2 options, then if you were to use the first one for your network number and the second one for your broadcast, you wouldn't have any available addresses to use within each subnet. So you really need to borrow 2 bits. Okay? So 2 to the second would be 4 numbers. Now your mask for each of these would be the 252. Okay? /30 or 252 because of the value all the way across. So let's look at what your network numbers would be. Now your first one is 1.0. So if you do it using this method that I was referring to, one of the other things that would make it a little bit easier, I'm going to add in another column here. So looking at /26, we said that would actually give you 64 hosts. So I'm going to type that in here. Again, same thing here, 64 hosts. We said that the /27 really accommodates for 32 hosts. This would accommodate for 16. And each of these are 4. So by doing that, then you can just use math to solve this equation, I guess if that's what you want to call it. So 192.168.1.0. Now remember that 0 is your starting point when working with IT, and that really throws people a lot. But by starting with 0, 0 is your first number. Okay, I'm going to increment by the number that this accommodates for. So we said this accommodates for 64. So that means the next number that I would have would be the 64. Then 64 plus 64 equals 128. 128 and 32 equals 160. 160 and 32 equals 192. 192 plus 16, because I hope you understand what I'm doing is 16, we need 16 for this line. That's why we add it to 192, and that would give us the starting point for the next one, which would be 208. So 208, we need to accommodate for 16, so 208 and 16 would be the 224. 224 needs to accommodate for 4, that one's an easy one, so that's 228. Same thing here, and that's 232. So this will be our starting point or our network number. So if I were to draw your columns, so this is the number of hosts. This would be the CIDR notation. This would be the number of hosts that it accommodates for. So total number of hosts. This is your subnet mask. This is your network number. And this is your broadcast. Now, your broadcast number is your last available number in the subnet. So if your network number is your first available number, your broadcast is the very last. So if you determine all your network numbers, then you can just drop one below to get your broadcast. So the broadcast in this scenario would be the 192 2.168.1.63 because that is the last number available before it reaches the next subnet. So the range in this octet would be 192.168.1.0 through 1.63. This one is 64 through and would cut off at 127 because you can see the next one starts at 128. So this one would be 192.168.1.128. I'm sorry, 127. The next one would do the same thing. 192.168.1.159. Okay, just for the sake of time, I paused the video and included the other numbers. So I just really kind of went with each subnet one number up from whatever the next subnet began with. So 1.0 through 163 as the broadcast number, 1.64 through 127, 128 to 159, the next one begins at 160, and I just did each one. And this is my network number in my broadcast. So this is the network number that's associated for anything in the network. The broadcast is this one. These are not valid addresses, but you can use anything in between. So in this scenario, I can use 1.1 through, let me just do the last number. So 1 through 62. The next one I could use 65 through 126. The next number I can use 129 through 158. 161 through 190. And this one, 193 through 206. 209 through 222. 225 and 226. Notice two numbers available under serial connections. 229 to 230 and 233 through 234. So these are my usable numbers. So this actually accidentally auto-corrected for me. So I had some formatting set up. So this is 1.1 through 1.62. Okay. So these give you our usable numbers. So these are the assignable numbers, the numbers we would assign to an interface. And then you can assign the numbers in between too. Most of the instructions will ask you to use your first and last available. So this is what I have typed here just to make it a little bit easier on us as we're going through the curriculum. Okay, so looking at our instructions here, this is asking how many subnets we need. We have 9 and the maximum number. And then we figured out what our addresses were, and we started with the largest to smallest. And then you can actually assign these. So just by writing these from largest to smallest, it would help us actually assign these addresses. And then it says to assign the addresses to the individual router for each one. Now, we've already been able to figure out what each of these addresses are. So, headquarters 1 LAN, for example, we would need to accommodate for 50, and the headquarters LAN 1 is here. Now, we've already stated that the network number should be 1.0. So, you'll need to make sure whichever one you accommodate for, that you include that in your network. So if you accommodate for 50, you can't assign it to a completely different LAN because it wouldn't fit, because it wouldn't accommodate for the numbers that are here. Now again, just to save time, I have already typed these in just so that I can make it a little bit quicker. So what I'm actually doing is just writing each of these in. So this is the 1.0. This is the one that's accommodating for the next one, okay, for the 50. And then we have your next two networks. So these are all the LANs that we have. So I'm following the directions that are in this tutorial down at the bottom. I'm just kind of doing this in my own method. So right here, we're assigning the subnets to the headquarter LANs. Okay. Here it's asking us the subnet information for the links between the routers. We already know that you need 2 addresses between each of the subnets, so 1, 2. And we've already calculated how many we need in our mask, and it will always follow the /30 or the 252 mask for your serial links. So really all we've done is, once we fill out our table, that's the hard part, and then we just apply all of this information. So these are each of our networks. So that's pretty cool. Now, by following the directions that we have here, let's look at this. Assign the IP addresses to the network devices. So this is where it gets tricky for a lot of people because you get kind of confused. Well, if you have your chart that you worked on, that helps a whole lot. So step 1, assigning the addresses to the router. Assign the first valid host address in the HQ LAN 1, which is up here, to the FA0/0 interface. So you're assigning the first valid host address to this interface right here. Well, since we already wrote that out, we already know that it's 1.1. So you would assign that to the FA0.0, the 1.1. So I have already completed that, and we know that our mask is this 192. So then for the next one, the first available, okay, if the network number is 64, then that means our first available will be 65. In your mask. Okay, for the serial, we know that the whole network address is the 224. Let's see, they tell us what to use for that. Okay, the first valid host address in this link to the S000 interface. So that means it would go here, either 225. So the first network number is 225. That means this will be 225 here, 226 here, okay, on the 224 LAN. Okay, and you would just follow your instructions to complete the rest, the remaining part. So the S000, you would that. Okay, so it was 228, so the first one is 229, and that would be 230. And I'll just complete the remaining here. So it's just using the information from your chart to complete for each one of these. And then what you do is put together what you've learned so far with your configuration, and you would go into each device and you would have all of your addresses and configure those for each of your interfaces. So hopefully this gives you a good scenario of how to take a topology, figure out the number of subnets that you need, figure out how many hosts you have on each one, your associated CIDR value, subnet mask, your network number, broadcast, and then once you get that figured out, then you can determine what your usable numbers are and then apply that according to the directions. I hope this is helpful in doing a basic VLSM calculation. This is the same method I use every time. You might have a different method, but this is the method that I tend to use consistently. Because it's like with anything else, once you determine a method that works for you, as long as it works, then keep using that method. Try not to use your calculators because you can't use those on any of your certification exams. By understanding this, it will help you. In the real world, are you going to have to subnet? No, you won't. You will probably be using a calculator, or it will already just be done for you. But you will need to know this knowledge when you're filtering information later, when you get into your other courses and you're filtering based on wildcard mask. You will need to know the associated subnet mask and filter based on a particular subnet. So that's where that will really come into play. But you will also see questions on your CCNA exam if you plan on taking that as well. You will have to determine if an address is configured correctly. You might also have to answer questions based on multiple choice on a particular subnet and valid addresses. So that would be the other reason for learning your subnetting. So I hope this has been helpful. Feel free to ask questions if you're not clear about something in the video.